Welcome to AZ-802 Practice Exam, Hyper-V and Virtual Machine Management Deep Dive, Set 5. This focused session includes 45 original questions on Hyper-V guest management, nested virtualization, memory, integration services, device and GPU assignment, checkpoints, high availability, virtual disks, networking, Replica, and Windows Server virtual machines in Azure. I will read each virtual machine scenario and the answer choices. After the choices, you will hear, "Lock in your answer." Then the video pauses for a silent 3-second countdown. Pause the video if you need more time. After the countdown, I will reveal the correct answer, explain the deciding host, guest, cluster, storage, network, or Azure boundary, and share one exam clue you can transfer to another scenario. Question 1 of 45. An administrator uses VM Connect to manage a Windows 11 virtual machine on a local Hyper-V host. Basic session mode works, but the administrator needs clipboard, printer, audio, and local drive redirection without adding a virtual network adapter. Which guest configuration should the administrator perform first? Option A. Enable remote desktop inside the Windows 11 guest, and then reconnect with VM Connect in enhanced session mode. Option B. Enable the Hyper-V guest service interface and use copy VM file for all redirected resources. Option C. Create an external virtual switch and connect to the guest by using the remote desktop client. Option D. Enable MAC address spoofing on the guest network adapter and reopen VM Connect. Lock in your answer. The correct answer is A. Enable remote desktop inside the Windows 11 guest, and then reconnect with VM Connect in enhanced session mode. Enhanced session mode uses RDP through VM Connect and requires remote desktop to be enabled in the Windows guest. It can redirect the clipboard, printers, audio, drives, and supported devices without depending on the VM's virtual network configuration. Enhanced session mode carries RDP through VM Connect, so guest remote desktop must be enabled even when the virtual machine has no network connectivity. Question 2 of 45. Remote desktop is enabled in a Windows 11 guest. VM Connect reports that enhanced session mode is available, but after switching modes, the VM Connect background never displays the sign-in prompt. The guest uses a Microsoft account with Windows Hello only sign-in enabled. Which action should restore the enhanced session mode sign-in prompt? Option A. Disable the Hyper-V time synchronization integration service and restart VM Connect. Option B. In basic session mode, turn off the setting that permits only Windows Hello sign-in for Microsoft accounts, and then sign out or restart the guest. Option C. Disable and re-enable enhanced session mode in Hyper-V settings, then reconnect while retaining the guest's Windows Hello only sign-in policy. Option D. Enable guest service interface on the VM and restart the VMIC guest interface service. Lock in your answer. The correct answer is B. In basic session mode, turn off the setting that permits only Windows Hello sign-in for Microsoft accounts, and then sign out or restart the guest. For Windows 10 version 2004 and later, and Windows 11, a missing enhanced session mode sign-in prompt can result from the Windows Hello only Microsoft account setting. Disable that setting from a basic session, and then sign out or reboot before reconnecting. A Windows 11 guest can offer enhanced session mode, yet suppress its prompt when Microsoft account sign-in is restricted to Windows Hello. Question 3 of 45. A Windows Server 2022 VM runs locally on a Windows Server 2022 Hyper-V host. The VM's firewall is misconfigured, its network adapter is disconnected, and WinRM is disabled. From the host, a Hyper-V administrator must run a one-time repair script by using valid guest credentials. Which command pattern should the administrator use? Option A. Invoke command computer name app01 fail c repair/meth1 credential get credential. Option B. Enter PS session computer name app01 authentication Kerberos and then run C. repair/fixnetwork.ps1. Option C. Invoke command VM name app01 flipboard C. repair/fixnetwork.ps1. Credential get credential. Option D. New PS session HTTP username app01 username administrator, and then pass the session to invoke command. Lock in your answer. The correct answer is C. Invoke command VM name app01 filter C:/repair /fixnetwork.ps1 -credential get credential. PowerShell Direct uses the -VM name or -VMID parameter from the local Hyper-V host and works regardless of the guest's network configuration or remote management settings. Invoke command is appropriate for a single command or script and closes the connection when execution finishes. PowerShell Direct targets a locally running Windows VM by VM name or ID and bypasses both virtual networking and guest WinRM configuration. Question 4 of 45. A PowerShell Direct command worked against VM app02 on HV01. After a shared nothing live migration moved the running VM to HV02, the same -VM name command on HV01 reports that the VM name cannot be resolved. Guest credentials and the guest operating system are unchanged. What should the administrator do? Option A. Add app02 to trusted hosts on HV01 and rerun the PowerShell Direct command. Option B. Enable an HTTPS WinRM listener in app02 and retain the -VM name parameter on HV01. Option C. Restart the Hyper-V PowerShell Direct service in app02 while continuing to issue the command from HV01. Option D. Open the Hyper-V administrator session on HV02 and issue the PowerShell Direct command there. Lock in your answer. The correct answer is D. Open the Hyper-V administrator session on HV02 and issue the PowerShell Direct command there. PowerShell Direct requires the target VM to run locally on the host where the command is issued. After migration, HV02 is the local host for app02, so the administrator must invoke the VM session from HV02. Live migration changes which server is local to the VM. PowerShell Direct must originate on the Hyper-V host currently running that VM. Question 5 of 45. An automation job on a Hyper-V host must apply one idempotent configuration script to each locally running Windows Server VM. The job must not maintain sessions after each script completes, and guest network settings cannot be assumed. Which PowerShell Direct design best meets the requirements? Option A. For each VM, call invoke command with -VM name, -file path, and valid guest credentials. Option B. For each VM, create a new PS session with -VM name and leave the persistent session open for later reuse. Option C. For each VM, call enter PS session with -computer name and disconnect the interactive session after the script runs. Option D. For each VM, create an SSH session to its IP address and invoke the Windows script through that session. Lock in your answer. The correct answer is A. For each VM, call invoke command with -VM name, -fossilangea, and valid guest credentials. Invoke command with -VM name and -files uses PowerShell Direct to run one script in a local Windows VM, regardless of network configuration. The connection closes automatically when the script finishes, matching the non-persistent automation requirement. A one-script automation task favors invoke command over persistent or interactive sessions, while VM name preserves independence from guest networking. Question 6 of 45. A lab VM named L1HV runs Windows Server 2022 on a supported Intel Hyper-V host. Its configuration version is 10.0. Engineers need to install Hyper-V inside L1HV and run second-level VMs. Which action should be performed before installing Hyper-V in L1HV? Option A. While L1HV is running, enable guest-controlled cache types on the VM. Option B. Turn off L1HV, and on the physical host, run set VM processor-VM name L1HV-expose virtualization extensions $true. Option C. Inside L1HV, enable MAC address spoofing on every second-level VM before installing Hyper-V. Option D. Convert L1HV to a Generation 1 VM and attach a legacy network adapter. Lock in your answer. The correct answer is B. Turn off L1HV, and on the physical host, run set VM processor-VM name L1HV. Expose virtualization extensions $true. Nested Hyper-V requires the physical host to expose hardware virtualization extensions to the first-level VM. The VM must be off when set VM processor sets expose virtualization extensions to true. The stated Intel host and configuration version meet the documented prerequisites. Nested Hyper-V starts with processor extension exposure on the physical host, and that VM processor change requires the first-level VM to be off. Question 7 of 45. An AMD EPYC server runs Windows Server 2019 as a Hyper-V host. A running Windows Server 2022 VM at configuration version 9.3 must become a first-level Hyper-V host. Set VM processor with expose virtualization extensions enabled fails. Which two changes are required before the nested Hyper-V configuration can be enabled? Choose 2. Option A. Upgrade the physical Hyper-V host to Windows Server 2022 or later. Option B. Downgrade the VM configuration version from 9.3 to 8.0. Option C. Turn off the VM and then run set VM processor with expose virtualization extensions enabled on the physical host. Option D. Enable dynamic memory and raise maximum RAM while the VM remains running. Lock in your answer. The correct answers are A and C. Option A. Upgrade the physical Hyper-V host to Windows Server 2022 or later. Option C. Turn off the VM and then run set VM processor with expose virtualization extensions enabled on the physical host. For AMD EPYC or Ryzen processors, the Hyper-V host must run Windows Server 2022 or later, and the VM configuration version must be 9.3 or later. The VM already meets the version requirement, but it must be turned off before the physical host exposes virtualization extensions. AMD nesting requires a Windows Server 2022 or later host and configuration version 9.3. Exposing processor extensions also requires the target VM to be stopped. Question 8 of 45. A first-level Hyper-V VM hosts an isolated training environment in a public cloud. The cloud network does not permit MAC address spoofing. Second-level VMs need outbound connectivity while remaining hidden behind the first-level VM's address. Which networking design should the engineer implement inside the first-level VM? Option A. Create an external switch for the second-level VMs and enable MAC address spoofing on the first-level VM's network adapter. Option B. Create a private switch and configure port mirroring from each second-level VM to the first-level VM. Option C. Create an internal virtual switch and a NetNAT object. Then use the first-level VM's NAT adapter as the nested VM's gateway. Option D. Enable NIC teaming inside each second-level VM and map both adapters directly to the cloud network. Lock in your answer. The correct answer is C. Create an internal virtual switch and a NetNAT object. Then use the first-level VM's NAT adapter as the nested VM's gateway. Microsoft recommends NAT networking when MAC address spoofing is unavailable, including public cloud environments. An internal switch and NetNAT object in the first-level VM provide a gateway through which nested VMs can reach external networks. When an upstream network forbids nested MAC exposure, place an internal switch and NAT gateway inside the first-level VM instead of spoofing addresses. Question 9 of 45. A pooled VDI host runs many Windows VMs that need 4 GB to boot, but usually settle at 1.5 GB after sign-in. The team wants Hyper-V to reclaim idle memory while preserving enough startup memory for reliable guest boot. Which VM memory configuration should the team use? Option A. Use 1.5 GB of fixed memory and rely on smart paging for every cold boot. Option B. Use 4 GB of fixed memory and configure a 20% memory buffer. Option C. Enable dynamic memory with startup RAM and minimum RAM both set to 1.5 GB. Option D. Enable dynamic memory, set startup RAM to 4 GB, and set minimum RAM to 1.5 GB. Lock in your answer. The correct answer is D. Enable dynamic memory, set startup RAM to 4 GB, and set minimum RAM to 1.5 GB. Startup RAM must satisfy the guest's boot requirement. With dynamic memory, minimum RAM can be lower than startup RAM, so Hyper-V can reclaim unused memory after startup, which improves consolidation for idle or low-load VMs. Startup RAM covers the guest's boot peak, while a lower minimum RAM lets dynamic memory reclaim capacity after the workload settles. Question 10 of 45. A VM has dynamic memory enabled with startup RAM of 2 GB, minimum RAM of 1 GB, and maximum RAM of 16 GB. A Windows Server in-place upgrade requires 4 GB and fails early, even though the host has ample free memory. Which change directly addresses the upgrade failure? Option A. Increase startup RAM to at least 4 GB before rerunning the upgrade. Option B. Set maximum RAM to 32 GB and configure startup RAM as 2 GB. Option C. Raise the memory buffer percentage so Hyper-V commits 4 GB during setup. Option D. Increase the VM's memory weight so it outranks other VMs during contention. Lock in your answer. The correct answer is A. Increase startup RAM to at least 4 GB before rerunning the upgrade. During guest operating system installation or upgrade, the VM uses only the amount configured as startup RAM, even when dynamic memory is enabled. Raising startup RAM to the upgrade's minimum requirement is therefore the direct correction. Guest installation and upgrade consume only startup RAM, so a generous dynamic memory maximum cannot compensate for an undersized startup value. Question 11 of 45. A deployment process must copy a signed configuration package from a Hyper-V host into a running Windows Server VM by using copy VM file. Network connectivity to the guest is intentionally disabled. Copy VM file reports that the required service is unavailable. Which integration service should be enabled for the VM? Option A. Hyper-V Data Exchange Service. Option B. Hyper-V Guest Service Interface. Option C. Hyper-V Volume Shadow Copy Requester. Option D. Hyper-V Heartbeat Service. Lock in your answer. The correct answer is B. Hyper-V Guest Service Interface. Hyper-V Guest Service Interface provides the host-to-guest file copy channel used by copy VM file and does not require network connectivity. The service is disabled by default, so it must be enabled for this operation. Copy VM file uses Guest Service Interface over VMBus, a disabled by default integration service that remains independent of guest network connectivity. Question 12 of 45. Host-level backup software can capture a running Windows Server VM, but application logs show that the database was not quiesced, and the resulting backup is crash consistent. The backup product invokes host VSS correctly, and the VM must remain online. Which integration service path should the engineer verify and restore? Option A. Heartbeat on the host and vMight's heartbeat in the guest. Option B. Guest shutdown on the host and vMight shutdown in the guest. Option C. Backup volume shadow copy integration on the VM and the Hyper-V volume shadow copy requester service in the guest. Option D, data exchange on the host and vmic VP exchange in the guest. Lock in your answer. The correct answer is C, backup volume shadow copy integration on the VM and the Hyper-V volume shadow copy requester service in the guest. The Hyper-V volume shadow copy requester integration service coordinates guest applications and VSS with the host's backup operation. If that path is disabled or unhealthy, the host cannot obtain the intended application-consistent online backup through guest VSS coordination. Application-consistent online host backup depends on the guest volume shadow copy requester coordinating workload VSS writers with the host backup process. Question 13 of 45. A standalone Windows Server 2022 Hyper-V host contains a GPU that surveyDDA.ps1 identifies as assignable. A powered-off VM has been configured with automatic stop-action turn-off, guest-controlled cache types, and sufficient low and high MMIO space. The GPU is still enabled and owned by the host. Which sequence completes discrete device assignment correctly? Option A, add the device to the VM, disable it in the guest, and then dismount it from the host. Option B, dismount the device from the host, start the VM, and then enable the device on the host. Option C, disable the device on the host, mount it back to the host, and then call add VM assignable device. Option D, record the PCI location path, disable the device on the host, dismount it from the host, and then call add VM assignable device with that location path. Lock in your answer. The correct answer is D. Record the PCI location path, disable the device on the host, dismount it from the host, and then call add VM assignable device with that location path. DDA transfers ownership of the entire PCIe device. After preparing the VM, the administrator obtains the PCI location path, disables the device in the host, dismounts it from the host partition, and assigns that location path to the powered-off VM with add VM assignable device. DDA requires an exact ownership handoff. Identify and disable the PCIe device, dismount it from the host, then assign its location path to the VM. Question 14 of 45. An engineer successfully dismounts a supported GPU from a standalone Hyper-V host and assigns it to a powered-off VM by location path. When the VM starts, Device Manager reports that the GPU cannot find enough free resources. The vendor driver is current and supports virtualization. Which VM configuration should the engineer review first? Option A, the VM's low memory mapped I/O space and high memory mapped I/O space values relative to the GPU's MMIO requirements. Option B, the VM's dynamic memory buffer percentage relative to the host's available memory counter. Option C, the VM's DDA location path assignment and automatic stop action settings. Option D, the host's Hyper-V heartbeat service status and VM health state. Lock in your answer. The correct answer is A, the VM's low memory mapped I/O space and high memory mapped I/O space values relative to the GPU's MMIO requirements. A DDA device that reports insufficient resources commonly lacks enough MMIO space inside the VM. The engineer should calculate the device's requirements and adjust the VM's low and high memory mapped I/O spaces, rather than changing unrelated memory, network, or health settings. A DDA device, visible but resource-starved inside the guest, points to insufficient low or high MMIO allocation, not ordinary guest RAM pressure. Question 15 of 45. A private cloud team must divide one physical GPU among several Hyper-V VMs. Each VM requires a dedicated fraction of GPU resources, a hardware-backed isolation boundary, predictable performance, and access through the GPU vendor's supported driver model. Which two design actions align with Microsoft guidance for GPU partitioning? Choose two. Option A, Deploy the workload on Windows Server 2025 Hyper-V hosts, and use GPU-P to assign dedicated GPU fractions to the VMs. Option B. Use DDA to assign the same physical GPU concurrently to every VM that needs acceleration. Option C. Keep Windows Server 2022 on the hosts, and emulate GPU partitions by dividing dynamic memory among the VMs. Option D. Select GPU-P-capable SR-IOV hardware, and use the GPU vendor's supported driver in each accelerated guest. Lock in your answer. The correct answers are A and D. Option A. Deploy the workload on Windows Server 2025 Hyper-V hosts and use GPU-P to assign dedicated GPU fractions to the VMs. Option D. Select GPU-P-capable SR-IOV hardware and use the GPU vendor's supported driver in each accelerated guest. GPU partitioning begins with Windows Server 2025 and uses SR-IOV to provide hardware-backed partitions with predictable performance and isolation. Each VM receives a dedicated fraction of the physical GPU and uses the GPU vendor's driver. This supports higher VM density than whole device DDA. GPU partitioning with hardware isolation and vendor drivers requires Windows Server 2025 GPU-P plus SR-IOV hardware rather than whole device DDA. Question 16 of 45. A Windows Server 2025 Hyper-V host has one supported SR-IOV GPU. The current DDA design accelerates one VM successfully, but 7 additional inference VMs remain CPU-bound. The application supports the vendor GPU driver and does not require exclusive access to the entire device. Which change best increases accelerated VM density while preserving isolated, predictable GPU allocations? Option A. Retain DDA and call add VM assignable device for the same GPU on all 8 VMs. Option B. Replace whole device DDA with GPU-P and assign a dedicated GPU partition to each inference VM. Option C. Retain DDA, enable dynamic memory on every VM, and raise each VM's memory weight. Option D. Replace DDA with an enhanced session mode connection, so each VM receives redirected host GPU resources. Lock in your answer. The correct answer is B. Replace whole device DDA with GPU-P and assign a dedicated GPU partition to each inference VM. DDA assigns the whole physical GPU to at most one VM, producing low VM density. GPU-P on Windows Server 2025 divides a supported SR-IOV GPU into dedicated fractions for multiple VMs, providing hardware-backed isolation and predictable performance per partition. When one GPU must accelerate many VMs, GPU-P removes DDA's one GPU to one VM density limit by allocating secure, predictable fractions per guest. Question 17 of 45. Before patching a production database VM, you need an application-consistent checkpoint. If guest backup integration cannot create one, Hyper-V must not silently capture memory state instead. Which checkpoint configuration should you apply? Option A. Configure standard checkpoints so Hyper-V captures the VM disk and memory state before patching. Option B. Configure production checkpoints so Hyper-V can fall back to a standard checkpoint when production checkpoint creation is unavailable. Option C. Configure production-only checkpoints so Hyper-V uses VSS or file system freeze and does not fall back to a standard checkpoint. Option D. Disable checkpoints and export the running VM configuration and virtual disks before each patch cycle. Lock in your answer. The correct answer is C. Configure production-only checkpoints so Hyper-V uses VSS or file system freeze and does not fall back to a standard checkpoint. Production only requires a production checkpoint, which uses VSS for supported Windows guests or file system freeze for Linux guests, and omits memory state. If that application-consistent method fails, Hyper-V does not substitute a standard checkpoint. Production only uses VSS, or file system freeze, without memory state, and blocks standard checkpoint fallback when application consistent checkpoint creation cannot complete. Question 18 of 45. A VM has a long checkpoint chain, and its host volume is nearing capacity. Operations must reclaim space while preserving the VM's current state and supported disk chain handling. Which cleanup configuration should you use? Option A. Compact the VM's base VHDX with edit virtual hard disk, create a new checkpoint, and retain the existing AVHDX chain. Option B. Export the newest checkpoint, delete the VM registration, and import the exported checkpoint as a replacement VM. Option C. Convert each AVHDX to a fixed VHDX, attach the converted disks to the VM, and retain the original checkpoint tree. Option D. Delete the selected checkpoints or checkpoint subtree through Hyper-V Manager or remove VM checkpoint, and allow Hyper-V to merge the AVHDX files. Lock in your answer. The correct answer is D. Delete the selected checkpoints or checkpoint subtree through Hyper-V Manager or remove VM checkpoint, and allow Hyper-V to merge the AVHDX files. Deleting checkpoints through Hyper-V initiates the supported merge of each AVHDX into its parent VHDX, and then removes the AVHDX. Direct file deletion can break the differencing chain and is explicitly unsupported. Checkpoint deletion is a managed merge operation. Remove checkpoints through Hyper-V so AVHDX contents merge into parents. Never delete AVHDX files directly. Question 19 of 45. An update produced unexpected behavior. You must revert to yesterday's checkpoint, but retain a checkpoint of the VM exactly as it exists now for later forensic comparison. Which checkpoint operation should you select? Option A. Select Create Checkpoint and Apply for yesterday's checkpoint, preserving the current state before Hyper-V restores the selected point. Option B. Select Apply for yesterday's checkpoint, then create a new checkpoint after the restored VM starts. Option C. Delete yesterday's checkpoint subtree, then create a checkpoint from the VM's remaining current state. Option D. Export yesterday's checkpoint as a separate VM, then delete all checkpoints from the original VM. Lock in your answer. The correct answer is A. Select Create Checkpoint and Apply for yesterday's checkpoint, preserving the current state before Hyper-V restores the selected point. Create Checkpoint and Apply first captures the VM's present state, and then applies the selected earlier checkpoint. This preserves the evidence point while returning the workload to yesterday's state. Create Checkpoint and Apply preserves the present VM state before restoring an earlier checkpoint. Apply alone provides no undo point for the current state. Question 20 of 45. 4 Hyper-V hosts must restart a production VM automatically on another local host after a node failure. Every node must access the VM configuration and disks. Which architecture should you implement? Option A. Configure each host as a Hyper-V replica server, and asynchronously replicate the VM among node local volumes. Option B. Create a Windows Server failover cluster. Place the VM configuration and virtual disks on shared storage accessible to every node, and add the VM as a clustered role. Option C. Create identical VM definitions on every host. Store each copy on local VHDX files, and synchronize guest data with DFS replication. Option D. Configure shared nothing live migration among the hosts, and schedule periodic migrations to distribute the production VMs. Lock in your answer. The correct answer is B. Create a Windows Server failover cluster, place the VM configuration and virtual disks on shared storage accessible to every node, and add the VM as a clustered role. Failover clustering monitors node health and transfers a clustered VM role after failure. All cluster nodes require access to the VM's configuration state and virtual disks through shared block storage or SMB 3.0 file storage. Local automatic VM restart requires a failover clustered role plus configuration and virtual disks on storage accessible to every possible owner node. Question 21 of 45. A new Hyper-V cluster uses SMB 3.0 storage. Live migration bursts must not delay heartbeats, and loss of one storage path must not interrupt VM disk access. Which two configurations should you implement? Option A, place management, cluster heartbeat, live migration, SMB storage, and VM access traffic on one untagged subnet with equal QoS weights. Option B, use a dedicated network or VLAN for live migration. Allow cluster communication without client connectivity, and restrict migration to the selected network. Option C, provide at least two same type, same speed storage adapters and use SMB multi-channel so storage connectivity can use multiple paths. Option D, combine the RDMA storage adapters into an LBFO team and expose one management OS adapter for SMB, heartbeat, and migration traffic. Lock in your answer. The correct answers are B and C. Option B, use a dedicated network or VLAN for live migration, allow cluster communication without client connectivity, and restrict migration to the selected network. Option C, provide at least two same type, same speed storage adapters, and use SMB multi-channel so storage connectivity can use multiple paths. A dedicated or VLAN-isolated live migration network prevents migration saturation from affecting cluster heartbeats. SMB multi-channel uses multiple suitable adapters for high-performance, resilient storage connectivity without requiring an LBFO team. Protect heartbeat latency by isolating live migration. Protect SMB storage paths with multiple matching adapters and SMB multi-channel, not RDMA disabling LBFO teaming. Question 22 of 45. A Hyper-V cluster has two RDMA-capable adapters per node for SMB storage. The design must preserve SMB Direct while tolerating an adapter or path failure. Which storage network design should you use? Option A. Create an LBFO switch-independent team from both RDMA adapters and bind one SMB client interface to the team adapter. Option B. Create an LBFO switch-dependent team from both RDMA adapters and configure Hyper-V port as the load balancing algorithm. Option C. Keep the RDMA adapters unteamed, configure separate SMB-capable interfaces and paths, and allow SMB multi-channel to use both adapters. Option D. Bind both RDMA adapters to one external virtual switch, disable SMB multi-channel, and configure one Management OS SMB adapter. Lock in your answer. The correct answer is C. Keep the RDMA adapters unteamed, configure separate SMB-capable interfaces and paths, and allow SMB multi-channel to use both adapters. NIC teaming is incompatible with RDMA capability. Keeping the adapters unteamed allows SMB Direct to use RDMA, while SMB multi-channel automatically uses multiple eligible interfaces for throughput and path resiliency. RDMA storage adapters stay unteamed. SMB Direct preserves low overhead transport, while SMB multi-channel supplies parallel paths and resilience across eligible interfaces. Question 23 of 45. A new database VM needs a 12 terabyte virtual data disk, power failure metadata protection, and predictable low overhead I/O. Compatibility with pre-Windows Server 2012 Hyper-V is unnecessary. Which virtual disk configuration should you create? Option A. Create a dynamically expanding Hyper-V VHD virtual data disk and attach it to an IDE controller. Option B. Create a fixed VHD attached to a virtual SCSI controller. Option C. Create a dynamically expanding Hyper-V VHDX virtual data disk and attach it to an IDE controller. Option D. Create a fixed VHDX attached to a virtual SCSI controller. Lock in your answer. The correct answer is D. Create a fixed VHDX attached to a virtual SCSI controller. VHDX supports virtual disks up to 64 terabytes and logs metadata updates for power failure resilience. A fixed file has the lowest mapping overhead, and Virtual SCSI is the preferred non-OS disk controller. A disk larger than VHD limits with power failure metadata protection points to VHDX. Fixed allocation and Virtual SCSI minimize data disk overhead. Question 24 of 45. A VM disk must move periodically between a current Hyper-V host and an older Hyper-V release that does not support VHDX. The disk needs only 500 gigabytes. Which disk format plan satisfies the compatibility constraint? Option A. Keep the virtual disk in VHD format and verify its required capacity remains within VHD limits. Option B. Convert the disk to VHDX and configure a 512-byte logical sector size before each move. Option C. Convert the disk to a dynamically expanding VHDX and attach it through Virtual IDE on both hosts. Option D. Create a fixed VHDX, then attach the same file as a pass-through disk on the older host. Lock in your answer. The correct answer is A. Keep the virtual disk in VHD format and verify its required capacity remains within VHD limits. Microsoft recommends VHDX for current deployments, but identifies compatibility with an earlier Hyper-V release that lacks VHDX support as a reason to retain VHD. The 500 gigabyte requirement fits within the older format's capacity. Retain VHD only when an earlier Hyper-V release must read the disk. Sector size or controller selection cannot add VHDX format support. Question 25 of 45. A backup VM may transmit at no more than 200 megabits per second through its Hyper-V Virtual Network adapter, even when the external switch has unused bandwidth. Which adapter configuration should you apply? Option A. Assign the VM adapter a minimum bandwidth weight value calculated as 200% of the switch default weight. Option B. Set the VM network adapter's maximum bandwidth to 200 megabits per second with Hyper-V Network QoS. Option C. Create an absolute minimum bandwidth switch and reserve 200 megabits per second for the VM adapter. Option D. Increase the VM adapter's VM queue weight until its assigned hardware queue processes no more than 200 megabits per second. Lock in your answer. The correct answer is B. Set the VM network adapter's maximum bandwidth to 200 megabits per second with Hyper-V Network QoS. Hyper-V Network QoS maximum bandwidth throttles outbound traffic from a virtual network adapter to the configured rate. Minimum bandwidth settings reserve service under contention. They do not impose a ceiling. Maximum bandwidth is an outbound ceiling on a VM adapter. Minimum bandwidth weight reserves a relative share only when the link is congested. Question 26 of 45. VMs live migrate between hosts with different available link capacity. Each service tier needs a proportional bandwidth guarantee during congestion, without blocking migration to a slower destination. Which Hyper-V QoS configuration should you use? Option A. Create the virtual switch in absolute mode and assign every tier a fixed minimum rate equal to its fastest host capacity. Option B. Enable data center bridging and Hyper-V minimum bandwidth on the same NIC and assign identical priorities to all tiers. Option C. Create the virtual switch in wait mode and assign gapped relative minimum bandwidth weights to the VM adapters by service tier. Option D. Configure maximum bandwidth caps for each VM adapter according to its service tier. Lock in your answer. The correct answer is C. Create the virtual switch in wait mode and assign gapped relative minimum bandwidth weights to the VM adapters by service tier. Wait mode repartitions available bandwidth proportionally and remains compatible with live migration and NIC teaming. Gapped weights such as 5, 3, and 1 clearly differentiate service tiers without requiring fixed spare Mbps on every destination. Wait mode follows available capacity across migrations. Absolute minimum MPPS can strand a VM when the destination cannot guarantee that fixed reservation. Question 27 of 45. A clustered Hyper-V host has two non-RDMA physical adapters connected to different physical switches. The host must survive either one adapter or one switch failing. Which host networking configuration should you use? Option A. Create a switch-dependent host team using static teaming and connect both adapters to separate physical switches. Option B. Attach one physical adapter to an external virtual switch and configure the second adapter as a standby inside each guest VM. Option C. Create one private virtual switch per physical adapter and bridge the switches inside the management operating system. Option D. Create a switch-independent team in the management operating system using Hyper-V port load balancing. Then bind the external virtual switch to that team. Lock in your answer. The correct answer is D. Create a switch-independent team in the management operating system using Hyper-V port load balancing. Then bind the external virtual switch to that team. Physical adapter teaming belongs in the management operating system. Switch-independent mode does not require switch participation and can span different switches, providing switch failure resilience. Hyper-V port is the recommended clustered Hyper-V load balancing mode. Host physical NIC resilience is configured in the management OS. Switch-independent mode can span switches, while Hyper-V port distributes virtual adapter traffic. Question 28 of 45. A network appliance VM must control failover between two guest network paths. Host administrators must leave the existing physical NIC team unchanged, and the guest OS must own the team. Which configuration preserves the required host versus guest boundary? Option A. Add two virtual network adapters to the VM, enable the required MAC address spoofing support on both adapters, and create the supported team inside the guest operating system. Option B. Add the host's two physical team members directly to the VM and create a switch-dependent team inside the guest operating system. Option C. Replace the host physical team with two private virtual switches and configure the guest to bridge one adapter from each switch. Option D. Create a second physical NIC team in the management operating system and expose its individual member adapters as guest network adapters. Lock in your answer. The correct answer is A. Add two virtual network adapters to the VM, enable the required MAC address spoofing support on both adapters, and create the supported team inside the guest operating system. Guest teaming is built from multiple virtual network adapters presented to the VM, not from the host's physical team members. Enabling the required MAC address spoofing support permits the guest team to send traffic using the team's MAC behavior while leaving host teaming intact. A guest-owned team combines VM virtual adapters and needs compatible MAC behavior. It never takes ownership of the host team's physical members. Question 29 of 45. VMs and the Hyper-V management operating system must share one physical adapter to reach the production LAN. The host must retain its management connection after switch creation. Which two settings should you configure? Option A. Create an internal virtual switch so VM and management OS adapters communicate without binding the switch to a physical adapter. Option B. Create an external virtual switch and bind it to the physical adapter connected to the production LAN. Option C. Create a private virtual switch and attach both the VM adapters and a management OS virtual adapter to it. Option D. Enable Allow Management Operating System to share this network adapter on the external virtual switch. Lock in your answer. The correct answers are B and D. Option B. Create an external virtual switch and bind it to the physical adapter connected to the production LAN. Option D. Enable Allow Management Operating System to share this network adapter on the external virtual switch. An external switch binds to a physical adapter and gives connected VMs access to the external LAN. Allow Management OS creates or retains Management OS connectivity through that same external switch and adapter. External identifies the physical LAN uplink. Allow Management OS separately determines whether the host keeps a virtual adapter on that shared external switch. Question 30 of 45. Two test VMs must communicate with each other and with diagnostic tools in the Hyper-V management operating system. They must have no direct connection to any physical network. Which virtual switch should you configure? Option A. Create an external switch bound to a disconnected physical adapter and allow the management operating system to share it. Option B. Create an internal switch and connect both VM adapters and the management operating system to that virtual network. Option C. Create a private switch and connect both VM adapters while adding a Management OS adapter to the private switch. Option D. Create an external switch bound to the production adapter and configure a private VLAN for the management operating system. Lock in your answer. The correct answer is B. Create an internal switch and connect both VM adapters and the management operating system to that virtual network. An internal virtual switch permits communication among connected VMs and the management operating system without binding to a physical network adapter. A private switch excludes the management OS. Internal switches join VMs and the management OS without a physical uplink. Private switches exclude the host, while external switches bind physical networking. Question 31 of 45. A standalone Hyper-V host in one untrusted domain must replicate a VM to a host in another untrusted domain across a routed WAN. Replication traffic must be encrypted. Which authentication and listener configuration should you use? Option A. Use Kerberos authentication over HTTP port 80 and add both hosts to matching local Hyper-V administrators groups. Option B. Use Kerberos authentication over HTTPS port 443 and install a server authentication certificate only on the receiving host. Option C. Use certificate-based authentication over HTTPS, install valid certificates with client and server authentication EKUs on both hosts, and enable the HTTPS listener firewall rule on the receiver. Option D. Use certificate-based authentication over HTTP port 80, install matching self-signed certificates, and enable the HTTP listener rule on the receiver. Lock in your answer. The correct answer is C. Use certificate-based authentication over HTTPS, install valid certificates with client and server authentication EKUs on both hosts, and enable the HTTPS listener firewall rule on the receiver. Untrusted domains cannot use the required Kerberos trust path. Certificate-based HTTPS removes the Active Directory dependency and encrypts replication. Valid certificates need both client and server authentication EKUs, private keys, trusted roots, and matching names. Untrusted domains plus encryption require certificate-based HTTPS. Both endpoints need trusted client and server auth certificates, while the receiver enables the HTTPS listener. Question 32 of 45. VMs replicate to a 4-node failover cluster. Replication succeeds while one node owns the target VM, but loses connectivity after ownership moves to another node. Which clustered replica configuration should replace the node-specific design? Option A. Configure every primary VM to use the current replica node's FQDN, and update each relationship after every cluster ownership change. Option B. Enable independent replica server settings on each cluster node, and store each node's replica VHDs on its local system volume. Option C. Create a generic clustered service name for each receiving node, and map primary VMs to those node-specific names in round-robin order. Option D. Configure an online Hyper-V replica broker client access point, target its FQDN from primaries, and store replica files on a location accessible to every cluster node. Lock in your answer. The correct answer is D. Configure an online Hyper-V Replica broker client access point, target its FQDN from primaries, and store replica files on a location accessible to every cluster node. The Hyper-V Replica broker is the clustered replication endpoint and remains a single contact as the Replica VM moves between nodes. Replica storage must be accessible to all nodes, such as a CSV path, and the broker must be online. Clustered replication targets the online Replica broker FQDN, not a node. Shared replica storage lets any node own the replicated VM. Question 33 of 45. The primary data center needs an offsite copy of selected VMs on a standalone Hyper-V host. Asynchronous recovery is acceptable. Automatic local restart is not the requirement. Which availability technology should you implement? Option A. Configure Hyper-V Replica from each selected primary VM to the offsite Hyper-V host. Option B. Create one stretched failover cluster and place all VM files on storage local to the primary data center. Option C. Schedule shared nothing live migrations of each selected VM to the offsite host every 5 minutes. Option D. Create standard checkpoints for each selected VM and copy only the AV-HDX files to the offsite host. Lock in your answer. The correct answer is A. Configure Hyper-V Replica from each selected primary VM to the offsite Hyper-V host. Hyper-V Replica asynchronously copies selected VMs between standalone hosts, clusters, or combinations of both, and is designed for recovery at another site. It is distinct from failover clustering's local high availability behavior. Hyper-V Replica maintains an asynchronous offsite VM copy for recovery. Failover clustering instead targets automatic workload availability among cluster nodes. Question 34 of 45. A Windows Server VM hosts a database whose files must persist independently of the VM and remain available after the VM is deleted and recreated. Which storage configurations should you use? Option A. Place the database files on the VM's temporary disk and enable host caching. Option B. Create an Azure Managed Data Disk, attach it to the VM, and store the database files on that disk. Option C. Create an Azure File Share and attach it to the VM as its operating system disk. Option D. Store the database files in the boot diagnostics storage location associated with the VM. Lock in your answer. The correct answer is B. Create an Azure Managed Data Disk, attach it to the VM, and store the database files on that disk. An Azure Managed Data Disk is durable block storage with a lifecycle separate from the VM resource. It can be detached and attached to another compatible VM, so deleting and recreating the compute resource does not require using temporary storage for persistent database files. Persistent block data with a lifecycle independent of compute belongs on a managed data disk, not the host-backed temporary disk. Question 35 of 45. After an Azure host maintenance event, a Windows Server VM starts normally, but application files previously stored on its temporary disk are missing. What should you change to prevent this data loss condition? Option A. Enable read-only host caching on the temporary disk before writing application files. Option B. Create a snapshot schedule for the temporary disk and restore the newest snapshot after maintenance. Option C. Move the application files to an attached Azure Managed Data Disk and reserve the temporary disk for disposable data. Option D. Assign a static private IP address to the VM's primary network interface before the next maintenance event. Lock in your answer. The correct answer is C. Move the application files to an attached Azure Managed Data Disk and reserve the temporary disk for disposable data. The temporary disk is host-backed and is intended only for data that can be lost, such as page files or caches. Application files requiring persistence belong on an Azure Managed OS or data disk. An attached managed data disk is the appropriate choice here. Data lost after a host event identifies temporary storage. Relocate every persistent application file to a managed OS or data disk. Question 36 of 45. One stateful Windows Server VM has sustained memory pressure. The application cannot run across multiple instances, and a brief planned restart is acceptable. Which capacity change should you make? Option A. Deploy a second application VM and distribute client sessions across both instances by using Azure Load Balancer. Option B. Convert the VM to an availability set so Azure can add memory during demand spikes. Option C. Create a VM scale set with the existing VM as its only instance and enable autoscale. Option D. Resize the VM to a compatible size with more memory, accounting for the required restart and possible deallocation. Lock in your answer. The correct answer is D. Resize the VM to a compatible size with more memory, accounting for the required restart and possible deallocation. Resizing vertically changes the CPU and memory capacity of the existing VM, which fits a stateful workload that cannot use multiple instances. A running VM restarts during resize, and deallocation can be required when the requested size is unavailable on its current hardware cluster. A single stateful workload needing more memory calls for vertical resize. Instance count autoscale helps horizontally scalable applications instead. Question 37 of 45. A team must correct two capacity problems. A single legacy VM needs a size unavailable on its current cluster, while a stateless web tier needs automatic instance count changes as demand varies. Which two actions address the respective problems? Option A. Deallocate the legacy VM, select the required compatible size when it becomes available, resize the VM, and start it. Option B. Add the legacy VM to an availability set after deployment so the requested size is allocated on its current cluster. Option C. Deploy the stateless web tier in a VM scale set and configure autoscale rules for its instance count. Option D. Resize one web tier VM whenever demand rises and rely on the load balancer to copy that size to its peers. Lock in your answer. The correct answers are A and C. Option A. Deallocate the legacy VM, select the required compatible size when it becomes available, resize the VM, and start it. Option C. Deploy the stateless web tier in a VM scale set and configure autoscale rules for its instance count. Deallocating a standalone VM can allow Azure to place it on hardware that supports the requested compatible size. A VM scale set centrally manages a group of VMs and can automatically increase or decrease instance count according to demand or a schedule. Deallocation can unlock sizes unavailable on the current cluster. Variable stateless demand maps to scale set autoscale, not repeated manual resizing. Question 38 of 45. A stateless Windows web service requires identical VM configurations, load-balanced traffic, centralized updates, and automatic horizontal scaling based on request demand. Which architecture best meets these operational requirements? Option A. Deploy the web service in a virtual machine scale set. Define the VM model, integrate load balancing, and configure autoscale. Option B. Deploy one VM in an availability zone and resize it whenever the request rate exceeds its CPU target. Option C. Deploy independent VMs in an availability set and update and resize each VM through separate schedules. Option D. Deploy one VM with multiple managed data disks and enable disk bursting for incoming web requests. Lock in your answer. The correct answer is A. Deploy the web service in a virtual machine scale set. Define the VM model, integrate load balancing, and configure autoscale. Virtual machine scale sets are designed to create and manage groups of load-balanced VMs, apply a centralized configuration model, coordinate updates, and automatically vary instance count. That horizontal architecture matches a stateless service with demand-driven capacity requirements. Identical, load-balanced instances, plus centralized updates and demand-driven instance count are four independent signals for a virtual machine scale set. Question 39 of 45. A two-tier application will run in an Azure region that supports availability zones. Its replicated VM instances must remain available if an entire data center loses power or cooling. How should you place the VM instances? Option A. Place all instances in one availability set to distribute them across update domains only. Option B. Deploy replicated instances across multiple availability zones within the region. Option C. Use zone-redundant storage for the managed disks of one regional VM as the application's availability design. Option D. Place all instances in one proximity placement group to minimize network latency. Lock in your answer. The correct answer is B. Deploy replicated instances across multiple availability zones within the region. Availability zones are physically separate locations within an Azure region, with distinct power, network, and cooling. Replicating application instances across zones protects against the loss of an individual data center in a way an availability set cannot. Loss of an entire data center is the decisive failure boundary. Replicated VMs must span availability zones with separate power, networking, and cooling. Question 40 of 45. A required Azure region does not support availability zones. 2 Windows Server VMs must be isolated from common hardware failures and planned maintenance where possible. Which deployment configuration should you use? Option A. Deploy both VMs independently with identical resource tags and no availability construct. Option B. Deploy both VMs in one proximity placement group and use separate managed data disks. Option C. Create a managed availability set and deploy both VMs into it so Azure distributes them across fault and update domains. Option D. Deploy one larger VM and create 2 Windows guest user sessions to represent the application instances. Lock in your answer. The correct answer is C. Create a managed availability set and deploy both VMs into it, so Azure distributes them across fault and update domains. In a region without availability zones, an availability set is the appropriate availability construct for related VMs. Azure assigns VMs in the set across fault domains and update domains, reducing correlated hardware and planned maintenance impact. When zones are unavailable, an availability set spreads multiple VMs across fault and update domains, reducing correlated hardware and maintenance outages. Question 41 of 45. A Windows Server VM may accept direct RDP only after an administrator requests approval for a specific source address and a limited access window. Which Azure feature should you configure? Option A. Publish RDP through Azure Load Balancer inbound NAT rules and restrict the front end with an NSG source address rule. Option B. Run Azure Network Watcher connection troubleshoot against TCP 3389 before allowing each administrator's RDP session. Option C. Azure Bastion native client support. Option D. Microsoft Defender for Cloud just-in-time VM access. Lock in your answer. The correct answer is D. Microsoft Defender for Cloud just-in-time VM access. JIT VM access keeps protected management ports closed and opens a requested port for an approved source IP and bounded time window. This directly matches the requirement for temporary request-based direct RDP access. A requested source IP, management port, and expiration window identify JIT access. Bastion instead supplies a managed private address connection path. Question 42 of 45. Administrators cannot reach a Windows Server VM because security removed its public IP and prohibits exposing inbound RDP from the internet. Browser-based portal access is required. Which service should you deploy for administrative connectivity? Option A. Deploy Azure Bastion in the virtual network and connect through the Azure portal to the VM's private IP address. Option B. Enable JIT access and request that TCP 3389 be opened from any internet source for the maximum interval. Option C. Create an inbound NAT rule on Azure Load Balancer and assign a new public front-end address. Option D. Enable IP forwarding on the VM's NIC and add a default route to the internet. Lock in your answer. The correct answer is A. Deploy Azure Bastion in the virtual network and connect through the Azure portal to the VM's private IP address. Azure Bastion provides RDP and SSH connectivity to VMs over their private IP addresses, including browser-based connections through the Azure portal. The target VM does not need a public IP or an internet-exposed RDP port. Browser-based RDP to a private VM without a public IP or internet-exposed management port is the defining Azure Bastion pattern. Question 43 of 45. Employees need portal-based RDP to private Azure VMs without public IPs. A vendor using its own RDP client separately requires approved, source-restricted access for 2-hour maintenance windows. Which two controls should you implement for the respective access paths? Option A. Deploy Azure Bastion and direct employees to connect through the Azure portal to each VM's private address. Option B. Assign public IP addresses to the employee VMs and allow TCP 3389 permanently from the corporate address range. Option C. Create one unrestricted inbound NAT rule for the vendor and rotate the VM administrator password after each visit. Option D. Configure JIT VM access for RDP and require the vendor to request the approved source address and 2-hour window. Lock in your answer. The correct answers are A and D. Option A. Deploy Azure Bastion and direct employees to connect through the Azure portal to each VM's private address. Option D. Configure JIT VM access for RDP and require the vendor to request the approved source address and 2-hour window. Bastion provides employee RDP through the Azure portal to private VM addresses without public IPs on the targets. JIT separately enforces request-based, source-specific, time-limited, direct management access for the vendor. Use Bastion for portal sessions over private addresses. Use JIT when a separate direct client needs approved source-bound expiring port access. Question 44 of 45. A Windows Server VM must retain the same private IPv4 address. Administrators currently configured that address manually inside Windows, and Azure reports a different NIC assignment. How should you correct the configuration? Option A. Reserve the address in Azure DNS and leave the conflicting static configuration inside Windows. Option B. Set the private IP assignment to static on the Azure NIC IP configuration. Then let the guest receive that address through Azure DHCP. Option C. Associate a static public IP address with the NIC and configure Windows to translate it to the desired private address. Option D. Create a user-defined route whose next hop is the desired private address and associate it with the subnet. Lock in your answer. The correct answer is B. Set the private IP assignment to static on the Azure NIC IP configuration. Then let the guest receive that address through Azure DHCP. Azure assigns a NIC's private address to the guest through its DHCP service. To retain a selected address, configure static allocation on the Azure NIC IP configuration, and avoid an independent guest setting that conflicts with Azure's assignment. Azure owns NIC address assignment and delivers it through DHCP. Reserve a private address on the NIC configuration, not independently inside Windows. Question 45 of 45. A Windows Server VM acts as a network virtual appliance between two subnets. User-defined routes target its private IP, but packets not addressed to the appliance are dropped. Which configuration change is required to make the forwarding path work? Option A. Assign a public IP to every NIC on the appliance and remove the user-defined routes. Option B. Associate both appliance NICs with one application security group and disable accelerated networking. Option C. Enable IP forwarding on each participating Azure NIC and configure the Windows appliance software or operating system to forward the traffic. Option D. Change each NIC's private IP allocation to dynamic and add the appliance to an availability set. Lock in your answer. The correct answer is C. Enable IP forwarding on each participating Azure NIC and configure the Windows appliance software or operating system to forward the traffic. An Azure NIC must have IP forwarding enabled to receive traffic not destined for its assigned addresses and send traffic with other source addresses. Azure's NIC setting is necessary but not sufficient. The guest must also run and configure forwarding-capable software or operating system routing. A UDR only selects the appliance as next hop. Transit traffic also requires Azure NIC IP forwarding and guest-level forwarding logic. You finished the Hyper-V and Virtual Machine Management Deep Dive. Sort any misses into 6 boundaries: host versus guest, compute and memory, device and GPU, storage and checkpoints, network and replication, or Azure availability and secure access. Replay only the patterns you missed to build a precise remediation plan. Thanks for practicing with WebLizard Cert Lab. Keep the management boundary, failure domain, data path, and access path in view. Then continue with the hybrid networking deep dive when you are ready.